Good morning and good afternoon. Welcome to Informatica's deep dive webinar on Big Data Management with Intelligent Data Lake. My name is Murthy Prakasam and I am joined by Informatica's Big Data Technical Solutions expert, Amit Kara, today. Now, as many of you might remember from last spring, Informatica launched its next generation of Big Data Management solutions, which also included a new product called Intelligent Data Lake. Based on the awesome customer demand, we're bringing to you an even closer look at these solutions today. As Informatica's Big Data Technical Solution expert, Amit Kara has a breadth of hands-on experience around practical applications of big data management solutions to solve essential business problems. Ultimately, today's event is intended to help you learn about how you can more quickly, flexibly, and repeatably power your business with big data. Now, in the spirit of providing a great overview, we will be showing you some actual screens from products. So we encourage you to expand your presentation window to full screen so you get the best viewing experience. And we also encourage you to submit questions in the Q&A window, although we may not be able to get to all of the questions in the time in the webinar. So we'll try to cover a couple questions and then we'll address the rest of them after the event. So with that great introduction, let me introduce our keynote speaker, Amit Kara, Big Data Technical Solutions expert at Informatica. Thank you for sharing some of your insights today, Amit.
Thanks, Murthy, for the introduction. In this first slide, what I wanted to do was recap what we introduced with Informatica Big Data Management 10.0, which we released back in November of last year. Informatica Big Data Management, or BDM, we provided organizations a gold standard in data management solutions for integrating, governing, and securing big data that businesses needed to realize big data value quickly. The solution provided a method to ingest, parse, profile, cleanse any type and govern any type of data quickly and repeatedly on Hadoop using hundreds of pre-built transformations, connectors, and parsers. From an IT developer perspective, in 10.0, we introduced the concept of dynamic mapping templates to speed up and simplify development efforts and maintenance. From the platform, we introduced Informatica Blaze and the Smart Executor, which added to Informatica's optimized support for multiple data processing frameworks by delivering a flexible, scalable, high-performance distributed data processing engine for Hadoop. In the context of Hadoop and polyglot computing, Informatica Big Data Management 10.0 supported MapReduce, Hive on Tez, and Informatica Blaze. And the Smart Executor was designed to decide at runtime which is the best execution engine to process the workload. So this is a very high-level overview of what we released in Informatica Big Data Management 10.0. So as our customers were successfully implementing big data projects using Informatica Big Data Management, we were getting a lot of feedback from our customers, and we were also looking at the new trends in big data management. For example, we were getting feedback that they wanted to collect everything, whether it's raw, refined, structured, unstructured, over an extended period of time. There were a new class of users, the analysts, the data scientists. They wanted to explore, reuse, refine the data sets on Hadoop in a self-service manner. And they wanted flexible access, whether it's batch, real-time, interactive, either on-premise or in the cloud. So let's take a look at some of the challenges that are faced by an organization. So I'm going to break this up into the IT folks and the business analysts, the data analyst folks. So from an IT perspective, right, they can't cope with the growing demand from the business, while the analyst is frustrated because they're not getting any response from IT just due to the long backlog. Now, business folks can't find trusted data because IT doesn't have the ability to govern and manage that data assets created on Hadoop. There's no visibility by IT into what the business is doing, and the business folks have limited access to that data, and it's constrained by either disparate desktop tools or manual steps in just accessing that data. So in the end, IT is failing to deliver value to business, while the business analysts, the data analysts, have got no way to collaborate, share, and update curated data sets. And here are some of the quotes directly from our customers on what they're seeing, right? The challenges that they're facing, based on that list that I just went off, right? So prepping and cleansing data is taking 2 to 3 weeks, sometimes longer. It's frustrating to see really promising data sets only to find out that it's really bad, or they've got no visibility into metadata for those data assets, and there's no way to provide visibility into data lineage. This feedback, the challenges that the customers face, and the new trends in big data management allowed us to look at how customers were implementing big data and how we as Informatica can enable IT agility and help business be self-sufficient. Informatica Big Data Management 10.1 continues to provide the most comprehensive end-to-end data management solutions for big data initiatives. With BDM 10.1, organizations can confidently design and develop data lake architectures that deliver fit-for-purpose data sets to different types of analytics users. Informatica's approach in big data management accelerates developer productivity, enables IT agility, and ensures business analyst autonomy in a fully secured and governed environment. Included in the Informatica Big Data Management 10.1 release is the Intelligent Data Lake. This is Informatica's latest innovation in big data management, where data scientists and other business users can now find, prepare, and protect data for analysis in a uniquely collaborative way that enables businesses to make decisions even faster. I wanted to spend a few minutes and talk about what's new in the big data integration pillar. In terms of performance and functionality, we've added more features and functionality to Blaze, what I call Blaze 2.0, and we've also introduced Spark as another processing engine. So what this means is that when I execute a mapping on the Hadoop cluster, the Smart Executor has an option to either use Blaze, Spark, Hive on MapReduce, or Hive on Tez to execute the workload. In terms of developer productivity, we've introduced a new feature called SQL to mapping, which means you can now convert your ANSI SQL statements to a big data mapping. And finally, in the developer productivity, we have a method where you can analyze your Power Center repository and determine which mappings can be converted to big data management mappings. And then finally, BDM on cloud, right? So now big data management supports AWS EMR and HD Insight, Azure HD Insight. So when we look at the polyglot engine that Informatica Big Data Management supports, the Smart Executor now has options, an added option to execute a mapping workload, right? Previously we could do Hive on MapReduce, Hive on Tez, and Informatica Blaze. Now we've added support for Spark. So again, like I said, the Smart Executor at runtime will determine which is the best execution engine to execute the workload, right? So it'll decide which one of these engines that it want to run on. So what happens when I submit a mapping to the Hadoop cluster and the cluster processes or use the Spark engine to process the data, right? So the data integration service sends the mapping to the Spark executor. Internally, what happens is the logical data translation manager translates the mapping into a Scala program, packages it as an application, and sends it to the Spark executor. The Spark executor then submits the application to the resource manager, in this case Yarn on the Hadoop cluster, and requests resources to run that application. The resource manager then identifies the node managers that can provide the resources, and it assigns the jobs to those data nodes. The Spark driver and Spark executor processes are launched in the data nodes where Spark applications run. So that's a very high level life cycle of what happens when I execute a mapping on the Hadoop cluster, and it leverages Spark as the execution engine. The PC reuse report functionality gives you an insight as to how many Power Center objects can be reused as big data management mappings and what actions are needed for you to convert these Power Center objects to big data mappings. Remember, the Power Center reuse functionality lets you bring in the Power Center mappings into BDM so that you can optimize it for big data management processing without having to build the mapping from scratch. All right, let's look at the SQL to mapping functionality introduced in Informatica BDM 10.1. The challenge that we see is handwritten SQL batch jobs require significant manual effort to translate into Informatica mappings, and that the developer needs to understand both the ANSI SQL and the Informatica mapping language and build the mappings from scratch. As part of this functionality, you can translate ANSI compliant SQL into Informatica Big Data Management mappings. So here in this slide, I have an example of a SQL statement and how it gets translated into a Informatica mapping. So you can see that the SQL to mapping functionality handles joins, where clauses, and group by functions as well. By default, it creates a flat file target, but you can easily change that to a Hive target or a HDFS target. Let's take a look at a very quick demo of how SQL to mapping functionality. So let me bring up my notepad that has a complex, well, I would consider a semi-complex SQL statement that's joining on two tables, line item and part table, joining on part key as my join condition. I have a pretty, I wouldn't consider this a complex where clause, but this gives you an idea of the types of SQL that we can convert to a mapping. So I'm going to go ahead and copy this to my clipboard. And I'm going to bring up my Informatica developer tool. This is a tool that I use to build out my mappings profiles that will run on a Hadoop cluster. So I'm going to open up my folder and click on mapping from SQL query. And here I can paste the query and it can scroll up. And you can see that the SQL statement is there. I have the option to select the SQL from a file, and I'm going to validate the query. And this should come back as a valid query. Yes, it does. Click OK. I'm going to name the mapping itself, and I'm going to go ahead and click on Next. So what this is doing is that it is going to parse the SQL, find what the tables are, match the tables to what is in the database and what's in my repository, and I'm going to click on Finish. And what it's going to do is going to go ahead, parse it, and convert it into a Informatica Big Data mapping. So here you see I have the mapping. I've got the two tables, line item and part table. I have my joiner transformation. If I look at the join condition, and I notice that I am joining on the part key. And I've got a filter transformation as well. Look at my filter condition. If I scroll down, and where we have that pretty complex where clause. And then I have my aggregator. I can look at my ports. Quick scroll down here. I can see that we're doing an aggregation, and I can write this out to a flat file or to a HDFS file, or I can write this out to a Hive table. I can also set up my validation environments where I'll select native, the Hadoop connections, and I can set up a Hadoop connection if I'm going to use this mapping to run on the Hadoop cluster. Okay, I'm in the developer tool, so I'm going to go ahead and walk you through a quick Spark demo. So I have a mapping that I created that's reading from a Hive table. It's doing an aggregation and an expression transformation and writing it out to HDFS. And as I mentioned, we added Spark as a additional processing engine that complements our polyglot compute engine, which consists of Hive on Tez, Hive on MapReduce, the Blaze, Informatica Blaze engine, and Spark. So here I can select the validation environments that will decide which is the best environment to execute this mapping and the workload on the Hadoop cluster. So when I look at the connection properties, look at my connection properties, you will see that I have a common attributes that point to my yarn resource manager, my HDFS. I've configured Hive pushdown. I've configured my Blaze connection object and my Spark engine. So I can click cancel because this is already pre-configured connection object. And when I run this mapping, BDM has a choice, decides at runtime where it will run. So here in my monitoring tool, I can see that the Spark, it chose Spark as the processing engine. I can look at the Spark execution plan again, the Spark execution plan, where, like I had mentioned, Informatica DIS converts the mapping to Scala programming language, and submits it to the Hadoop cluster. If I go back to the properties, I can track this mapping run on the Hadoop cluster by clicking on the monitoring URL. So this was a quick demo that covered SQL to mapping and the Spark demo. Okay, so the features that we've talked about up to now are very IT specific, right? It provided IT developers agility in context of big data management. So let's take a look at the next new feature introduced with Informatica Big Data Management 10.1. So before we start talking about the intelligent data lake, let me first introduce you to Live Data Map and how it is important as a service for big data management. So Live Data Map is a knowledge repository that is a functional part of the platform. It is not a separate product, but it is a service within the product. The knowledge repository collects metadata from across the platform and other tools and apps, and also usage statistics. And once it is in the repository, it can be used to analyze, discover relationship, power searches, and so on. The top layer of the diagram shows various products that will use Live Data Map repository to drive their capabilities, such as Enterprise Information Catalog, the Intelligent Data Lake, and Secure at Source. Some of the metadata services Live Data Map would support include indexing of the catalog of the metadata, right? Data profiling and statistical information, discovery of data domains, enrichment of the content. I will show some of the functionality as we go through the Intelligent Data Lake demo. So just a quick intro to one of the apps that I had talked about that uses Live Data Map services, and this app is called Enterprise Information Catalog, which helps you to analyze and understand large volumes of metadata in the enterprise. You can extract physical and operational metadata for many objects, organize the metadata based on business concepts, and view data lineage and relationship information of each object. The Enterprise Information Catalog maintains a catalog that serves as a central repository that stores all the metadata extracted from external sources. Enterprise Information Catalog extracts metadata from external sources such as databases, data warehouses, business glossaries, data integration resources, or business intelligence reports. For ease of search, and the catalog maintains an index inventory of all the data assets in the enterprise. Data assets represents the data objects such as tables, column, report, views, and schemas. Metadata statistical information in the catalog includes profiling results, information about data domains, and information about data relationships. Okay, so this is what everybody is waiting for, right? The Intelligent Data Lake. The Intelligent Data Lake is used to search, discover, and prepare data that resides in or outside the data lake. By definition, a data lake is a centralized repository of large volumes of structured and unstructured data. A data analyst or business analyst can use Intelligent Data Lake as a collaborative self-service tool to find, prepare, and share data assets. The analyst can prepare these data assets with little training or no coding, and they can use third-party tools to run reports and generate business insights in their data. Before we dive into the demo, let's look at some of the terminology. I will be using some of these terms quite a bit in the demo. So we already know what a data lake is, right? It's a centralized repository of large volumes of structured and unstructured data. And a data lake can contain different types of data, including raw data, refined master data, transaction data, log file data, or even machine data. In Intelligent Data Lake, the data lake is a Hadoop cluster. And a data asset is data that you would work on. And this data asset can be a flat file, a table, or a view. It could be stored in the data lake, or it could be stored outside of the data lake. A project is a container that stores the data asset and worksheets. Data preparation is a process of combining, cleansing, transforming, and structuring the data from one or more data assets so that it is ready for analysis. And a recipe includes a list of sources that you're working on and the steps that are taken to prepare that data. And finally, data publication, which is the process of making the prepared data available in the data lake. So when you prepare or when you publish a data set, the intelligent data lake writes the transformed data to a Hive table within the data lake so that other analysts can work on the data and share the data. Or the analysts can use third-party tools to run reports to further analyze the published data set. Okay, one more thing before we dive into the demo. Let me explain the process flow implemented when using the intelligent data lake and describe some of its unique features. First, the data engineers ingest the data onto the Hadoop platform using Informatica Big Data Management. When the data from the enterprise is offloaded to Hadoop, an analyst can discover data using live data map capabilities that I had just talked about to find and explore the most relevant data sets and enrich the data sets by capturing and sharing context across the organization while understanding data lineage across the enterprise and providing deeper metadata intelligence. As the data analyst searches for relevant data assets, the recommendation engine, an embedded machine learning based discovery engine, provides suggestions on related data objects being searched. Once the data assets have been identified, the analyst uses the intelligent data prep application to set up self-service data sets. The analyst can collaborate with colleagues by sharing work that they have done. The output results are then published for consumption by advanced analytic tools. Additionally, the self-service data preparation steps, known as recipes, can be operationalized. This means that the recipe is automatically translated into a Informatica Big Data mapping when published, and where the IT developer can automate the delivery of the data on a scheduled basis. So now that we've understood the flow, let's take a look and see how a data analyst used to create self-service data sets for a customer churn analysis. Let me set up the demo so you have context on how the intelligent data lake is used at a customer site. Wireless One is a fictitious telecom service provider that is faced with very high customer churn rate compared to its competition. To retain subscribers, the provider must proactively identify subscribers who are likely to churn and incentivize subscribers to stay. So the company's marketing department has been asked to create a customer churn analysis report to determine how to reduce customer churn. However, success has been constrained by the difficulty in accessing siloed data and by traditional IT approach of gathering requirements, designing, and building extracts to turn data into valuable data asset. As the IT organizations are backlogged with servicing business requests, business analysts and data scientists are looking for a self-service method to discover relevant data, share the data with colleagues across divisions or geographies, and prepare data assets for actionable insights. Using Informatica's intelligent data lake, I will show you how a data analyst at Wireless One used semantic search data discovery and self-service data preparation to rapidly discover and turn raw data into insights with quality and governance. The Intelligent Data Lake application is a web application that I access using an internet browser, either Microsoft Internet Explorer or Google Chrome. Here I'm going to actually log on using my Google Chrome browser. So when I log on to the application, the home view displays my recent projects, uploads, and publications. The projects view displays all the projects that I've created, that I'm working on, or collaborated on. And a project is nothing more than a container that I use to organize the worksheets and source data that I'm going to use to prepare my data set. Now, in this environment, this is a brand new environment that I just stood up a few days ago. That's why you don't see any new projects, but we'll be creating a few projects here as we go along in this demo. The My Activities view displays all the activities that I've completed. So these activities include searching, uploading, and publishing data sets to the data lake. Uploading data is a process of adding my own data to the Hadoop cluster from my local drive, right? So it could be on my desktop, it could be on my laptop. I can upload delimited text files to the data lake, and IDL stores this uploaded data as a Hive table on the Hadoop cluster. I'm going to start by creating a project called Customer Churn Analysis. The primary challenge is finding the relevant data sets for my customer churn analysis. In the top corner, I can search for data assets, or in the home view section, I can select search. Here I'll search for call detail records. The data discovery is done using live data map that quickly and easily finds and explores trusted data assets in one central catalog using semantic search and smart recommendations related to the call detail records in the enterprise. So regardless where that data is stored, it could be on Hadoop, it could be on EDW, it could be on a report. A live data map here displays the total number of data assets in the catalog along with the number of resources. I can look at the trending searches for data assets, or I can look at the top data sets or even recently viewed data sets. The search results page returns all the assets related to the CDR search, the call detail record search that I just searched for. I can use the following filters on the left-hand side to refine the search results. These filters will help me narrow down the data assets that I'm looking for based on my requirement. I can filter by asset type, which will filter based on table, resource, it could be a folder, or a resource type, which could be SAP Business Object, it could be an Informatica platform, it could be a relational database, or it could be on Hadoop. I can filter based on last update date, right? I can see what is the most recent data set that has been touched, or I can look by size. I'm interested in working with tables because I think this is the assets that I'm going to use for my churn analysis report. So here I'm going to select table. Now, when I select the call detail records table, Intelligent Data Lake displays the assets view that provides more information about the table that I had just selected. There are 4 tabs that are displayed here: the Overview tab, the Data Preview tab, Lineage, and Relationship. Let's take a look at each of these tabs to determine if it's worth adding Call Detail Records table to my project. The Overview window or view displays details of that selected asset, right? So I can see that this is a Hive table. It is in a particular schema. It has 10,000 rows and it was last updated. Looking on the left-hand side, I can see it as system attributes. That gives me a little bit more information about that data asset in terms of the total size, what the resource name is, and I see custom attributes. And it's interesting here because I can tell that this particular data asset called detail records coming from mainframe. Looking at the business description, I can see that it contains active and inactive customers, but it also tells me that I got to use this asset with caution, and I could expect some performance issues. So this is something that I have to take note of. It will tell me who the business owner is, the business unit, and it gives me trust rating, right? How do I flag this data asset? Is it a really good table that I should use or not, right? On the right-hand side, I can see integrated data profiling statistics of that table. Look at the name of the columns in that particular table, the number of null, unique, and non-unique values in that column. Look at the source data type and look at inferred data type, which basically means it's the data type that's derived from the source column. I can look at the data domains. This is data that matches patterns defined earlier. So for example, we'll look at a formatted social security number, a bank account number, or credit card numbers. Now remember, I noticed that in the custom attributes that it said use with caution. So I'll need to investigate further to see if there are other tables that I can use for my analysis. When I click the Data Preview tab, Intelligent Data Lake retrieves a sample set of that data. In this case, the first 500 rows of the data of call detail records that are stored in the data lake, that are stored on Hadoop. Based on what I've seen from the data statistics table and the preview of the data, this table contains log details of calls made by customers who canceled their subscription in previous years. The lineage view shows the start point of the data, describes the path, and shows how the data asset arrived at the endpoint. The lineage diagram shows the end-to-end data flow for that selected asset. So in this case, I can see that call detail records table that I'm working with actually was derived from a CDR detail table from the Oracle database. The SAP Business Object Report seems to be an interesting asset, so I can expand the lineage path, and this tells me that there are more objects in this data flow. So when I expand the lineage path, I can see all the assets, all the data assets that I use to make up this particular SAP Business Object Report. As I look at the different data assets in this particular flow, I notice a table called call records aggregate, which I believe is aggregate calls that are made by a particular customer. So I'm going to explore this call record aggregate table just like I did with the call detail records table. So I'm going to preview the data assets. I'm going to look at the data statistics, look at the profiling statistics, quick preview of the data, and then look at the relationship of the data itself. And I'm confident that I could use call detail record table as another data asset for my analysis. So what I'm going to do is I'm going to add this table to my churn analysis project. So I can explore relationships between call record aggregate table and other assets within the enterprise. And relationship view is a key feature of the Intelligent Data Lake application. Because what relationship view does, it displays the relationship in a diagram form that shows how selected data assets are related to other assets within the enterprise. So here I can see call record aggregate has relationships between other tables. It has relationship between reports and users. And interestingly, I can see which users have access to this particular data set. I navigate back to the call detail records table and I look at the relationships it has with other assets within the environment. So I can see here it has a relationship with table, it has a relationship with reports and users. What's interesting here is that it also has a relationship with a data domain called customer ID. I'm going to drill down into customer ID and discover what relationship it has in context of the data lake. The customer ID data domain has an association with columns as well as with tables. If I show all the tables here, this diagram now tells me what are all the tables in my environment that have customer ID associated with it. I look at in the center here, and customer master looks as is an interesting table. I wonder if I should include this into my analysis. I'm going to go ahead and drill down into customer master. So I'm going to go over to the overview tab. I'm going to look at some of the metadata descriptions that it has out there. And I'm going to see the integrated data profiling stats for this table. And I'm going to see whether if I should add this table to my project or not. This seems to be a table that I could definitely use. And if I preview the data, I can see what the data looks like before I add it to my project. So I'm going to go ahead and I'm going to add customer master to my project here. Okay, so now that I have the relevant data sets in my project, I'm going to start preparing this data for analysis. One thing I can do with projects is I can share project with other analysts to collaborate on activities related to this particular project. I'm going to add a collaborator to the project, and I'm going to add my colleague, Louis Noel, to this particular project because this is going to be a complex project in terms of doing analysis for customer churn. So I'll assign him edit permissions to the project, which means it's going to give him permissions to edit the project and the data sets as we go and build out this churn analysis report. If you recall, in the discovery and process analysis flow I described earlier, I talked about recommendations. When I scroll down in a project, I notice the recommendation view. Intelligent Data Lake makes recommendations based on data assets added to the project, and allows me to determine how best to make use of these recommendations. Here I can view recommendations for data assets used by different projects, by trusted people within the organization, or for data assets that share similar columns. Intelligent Data Lake makes two types of these recommendations. As I talked about, called additional recommendations, where assets that are used in different projects by different users, and alternative recommendations, data assets that share similar columns. So based on the recommendations here, I'm going to look at customer axiom table. Now, before I add this to the project, I'm going to view the asset properties just like I did with call detail records and customer master. So I'm going to look at the data profiling statistics, I'm going to look at the attributes, and I'm going to preview the data. Based on what I see, I trust this data set, so I'm going to go ahead and add customer axiom to my project. Now that I have all the data sets, I'm going to go ahead and prepare the data. As I said, right, data preparation is the process of combining, cleansing, transforming, and structuring data from one or more data assets so that it's ready for analysis. I'll go back to the project worksheet and I'll click Prepare. When I add a data asset to a project, Intelligent Data Lake creates a corresponding worksheet within this project. And a worksheet is an interactive data-driven spreadsheet interface. The worksheet will contain the data that I have prepared and recipes that track changes that I make to the data as I prepare it. And I'll show you this here in a second. Depending on the size of the data asset, Intelligent Data Lake will either load sample of the data or all the data within the worksheet. And as I prepare the data, I can see that it has 3 worksheets here for the 3 respective data assets that I'm going to be working on. I can get more information relevant to the data asset with suggestions and preview capabilities from the worksheet interface. When I click a column in the worksheet, Intelligent Data Lake analyzes the data and makes suggestions on how I can improve or manipulate the data. IDL displays the data analysis and suggestions in panels at the bottom of the worksheet. The overview panel shows how the column that contains email addresses and displays column details such as blank or duplicate values. Intelligent Data Lake also displays suggestions about how to manipulate the data in a suggestion panel. For example, the suggestion panel contains a suggestion to extract the domain name from an email. When I hover over the suggestion, IDL shows me a preview of the data manipulation. I'm going to go ahead and blend the data by combining 2 worksheets. I'm going to start by combining the customer axiom with the customer master data. In the preview of the combined worksheet, I can view the columns from the customer master data asset, columns from the customer axiom data set, and key columns that Intelligent Data Lake used to combine the worksheet. In the panel at the bottom of the worksheet, I can view details about the columns that Intelligent Data Lake used to make the key from the key columns, how much overlap there is between key columns, and which rows overlap. I determined that the preview of the combined worksheet looks correct, so I'm going to go ahead and click Combine. So at this point, Intelligent Data Lake created a combined worksheet. Now I can perform other data blending operations, or I can add formulas to this particular worksheet. Now I'm going to blend the newly created data set with call record aggregate. So as I did before, I can preview the combined worksheet and I can view the columns from both data sets and the key that IDL used to combine the worksheets. I'm content with this worksheet as well, and I'm going to go ahead and click Combine. Now that I have a combined data set, I can cleanse, transform, and structure that data. I can also perform data aggregation, right? So I would like to aggregate data by grouping data by column, content, or reporting data about each grouped column within my worksheet. In order to group by or aggregate the rows, I select the city column and I select Aggregate. IDL will now load the data to another worksheet, another dynamic worksheet. At the bottom of the screen, IDL offers suggestions on columns that I want to group by. I'm going to select city because that's what I want to group by, and I'm going to click continue. IDL also offers suggestions on columns to calculate on. I don't need the customer ID, so I'm going to remove this. I can update the preview and it will refresh the data sheet, the worksheet. And now I can see the subscribers in which city they are in and the count and the aggregate values. I'm going to aggregate the data, and IDL is going to create this worksheet for me that I can use for my churn analysis. I'm going to go back to my previous worksheet here. I can also apply common formulas to the worksheet, and Intelligent Data Lake provides hundreds of pre-built formulas which I can use to manipulate my data set. In this example, I want to find out the income levels of my subscribers, so I can quickly write up a function that will look at the income levels for all my subscribers. When I do that, Intelligent Data Lake will dynamically populate the new column with the derived logic. If I'm content with the formula, I can go ahead and click on Done. And now I have a combined worksheet that I can use for that I could publish to the data lake. I talked about recipes, and recipes are nothing more than actions that I've taken to create this worksheet. So think of a recipe, or think of it as an ingredient that make up a recipe. And when I follow these recipes, it builds up the final product, which is the data set. And I can look at the same recipes for the aggregate that I had built earlier. Okay, now I'm ready to publish the data set. And as I mentioned, data publication is the process of making prepared data available within the data lake. As I'm satisfied with the data sets that I've created, I look at my worksheets, and this tells me all the data sets that I am working on. I'm going to select the combined worksheet, and I'm going to publish this data set. I select the Hive database name that I'm going to populate the data sheet, and I can create or rename the Hive table, and I'm going to call this customer churn demo, and I'm going to click OK. So what IDL will do, will go ahead and publish this data on the Hive table. Now that the data has been published, I can go ahead and take a look at some of the properties, right? So I can go back and I can look at the overview tab, look at some of the statistics that are available for the data set that I have published to the data lake. Now that I have a published data set in the data lake, I can operationalize the data preparation steps. Recall the recipes that I had talked about. These recipes are automatically converted to an Informatica Big Data Management mapping. So here, when I go back to the developer tool, you can see that I have all the source data that creates the data sets, the call aggregates, the customer axiom, the customer master table that feed a maplet. When I expand the maplet here, I will be able to look at all the transformation steps that have been taken to populate my data set. So if I arrange the mapping in icon view, here are my two data sets that I used to populate to join on, the customer master, customer axiom, and then I use that to join to the call records aggregate table, and I write data out to a Hive table. So I look at the join conditions. It is joining on customer ID, and the second join, where I can see the master and the detail records, and I can see the aggregate as well, and writing it out to a Hive table. So when I go back to the original mapping, my IT team can now configure the mapping to execute using the polyglot engine, where this mapping will either run on Hive on MapReduce, Hive on Tez, Informatica Blaze, or Spark. This way, that when the mapping is scheduled to execute on the Hadoop cluster on a regular basis, which then can populate or refresh the data set that the analyst can use for further analysis. Alright, so to wrap up here, what I've shown you today is how Informatica's latest innovation, Intelligent Data Lake, leverages self-service efficiency for business analysts and data analysts by incorporating semantic search, data discovery, and data preparation for interactive analysis while governing data assets and collaborating with other analysts. Informatica's Intelligent Data Lake's capability extends to operationalizing and monitoring the data preparation process. This transforms the data preparation from a manual process into a reusable, sustainable, and operationalized system, and monitors the activities in the lake for better visibility and governance. And with that, I am going to hand it back to Murthy to open it up for Q&A.
All right, well, that was an awesome webinar, Amit. Thank you very much. So I know we have a few minutes left. Why don't we go ahead and take maybe just a handful of questions here? All right, here's a question here. Somebody's asking, is it possible for the business analyst to be able to add their own data into the data lake?
Yeah, you can. So the business analyst has the option to do that, and I showed that, right? In the UI, you have an option, or you have a button that says upload a file. So you can upload a delimited file. Now, just to expand on that, if you have Oracle source or relation or any other type of sources, typically your IT would ingest that data for you, right? So if you recall in the process diagram that I showed, I mentioned that IT would ingest the data from Oracle or cloud sources or anywhere else to the Hadoop Lake so that the analyst can consume that data.
All right, here's another question. So how do you operationalize the data preparation steps that you've built out?
So recall in the last step, right, you publish a data set. And what we do, or what the IDL application does, it tracks all these actions that you take in a recipe. And that recipe is translated into Informatica mapping. So your IT developer, your IT operations guy, can take that mapping and operationalize it and put it in production and make it run on a scheduled basis.
All right, here's a final question we've got. What sort of pricing and packaging for the Intelligent Data Lake? You know what, Amit, I can just probably take this question. So one of the great things, as Amit was mentioning throughout today's webinar, there is this interaction that we enable between IT and the business. And so we wanted to make sure to make this as simple as possible for our customers to adopt. So we've actually put Intelligent Data Lake as part of our Big Data Management package. So you'll actually be able to purchase Intelligent Data Lake as part of the IT-focused solution around Big Data Management that we already have. So it enables your IT teams to provide this self-service data preparation to their business users, and it really kind of reinforces the collaborative nature of the entire solution. All right, well, just wrapping up here. Thanks to everyone for joining today's webinar. We encourage you to check out some of our additional resources in the attachment section of the webinar, and we also encourage you to check out www.informatica.com/bigdataready, just as one word there, to sign up for our $1 million Big Data Ready Challenge, where you can win free licenses and free services to help deliver your next big data project. So thanks for joining, and best of luck powering your business with big data.